Learn smart, be wise. Learn with Sudip TECH LEARNING. Press the red button to subscribe. Like the video, share the video with friends and family.
Hello everyone, welcome to the part 2 of the important topics of SSC Science series that was started. Okay, in this part 2 we are going to study the second chapter, that is acids, bases and salts. Okay, now as the name of the chapter suggests, acids, bases and salt, this chapter you can directly say that it includes acids, bases and salts. Now we already have learned this chapter in 7th standard, 8th standard, 9th standard. The same name was there. Okay, acid, bases, salt, the same name, only every year a little bit of extra thing is coming in. Okay, so in this year also some extra things are coming. So let's start. First thing, before starting with this, I think I should tell you all about what are indicators. Okay, what are indicators? Indicators are substances that tell you either a given substance is an acid, or is it a base, or is it a neutral compound. Okay, now there are many types of indicators. First of it is this, that is the natural indicators. Now, examples of natural indicators you have to know. Before that, the definition of natural indicators is what? Naturally occurring indicators. Okay, you do not have to prepare them. That is called the natural indicators. Okay, what are the examples? Example is litmus and turmeric. Okay, these are naturally occurring. You don't have to make them. Okay, these are not man-made. These are naturally occurring indicators. Okay, so you have to know these examples: litmus and turmeric. Next is synthetic indicators. It is a type of indicator. Synthetic. What is synthetic? It is man-made indicators. Okay. Now, what is the example? Now, before example, I would say definition. Again, simple definition you can give of this. The indicators which are man-made or which are not naturally occurring are called synthetic indicators. Okay. Example, very important: phenolphthalein and methyl orange. Now, what I would like everyone to tell, that this word is important, phenolphthalein, and I am telling you all to please learn the spelling of this word, because the spelling is very important. Because most of the time the questions come in such a way that they are name the following, state, okay, or you have to write this in answer. Okay, and the main marks of that question are based on this word, and if you are not able to write this word, you don't know the spelling of this word, you're directly losing those marks. Okay, so my humble request is that you will have to learn this spelling, phenolphthalein. It's very easy, you can just break this, phenol and lean. Okay, phenolphthalein. Okay, spelling you have to learn. I'm again and again telling, because it is important. Okay, so these two examples you have to know. Next is olfactory indicators. Now, what are olfactory indicators? Substances which change odor. What is odor? Odor means smell. Now, when these substances are added to acidic or basic media, okay, based on what type of media it is used, these substances will change their odor. The smell will be changed, and therefore you can identify whether the given media is acidic or is it basic. These type of indicators are known as olfactory indicators. Okay, you have to remember along with the definition the examples. What are the examples? Vanilla, chloride and onion. Okay, very simple examples, you can remember this. Okay, so these were the three types of indicators that we have to know for this chapter. Okay, moving on to the next part, we have to learn how metals, metal carbonates, metal hydrogen carbonates, acids and bases, they are reacting. Okay, how metals react with acid. This is an important point. What is release? Now, when metal reacts with acid, what we get is salt and hydrogen gas is released. This is important to know. Whenever an acid is reacting with any metal, always there is evolution of hydrogen gas. Hydrogen gas is evolved there. Okay, So this point you have to remember. Okay. Next is metal carbonates. Metal carbonates, when they react with acid along with the salt, evolve carbon dioxide gas. Okay. So important point to note in this is evolving of carbon dioxide gas when acids are reacting with metal carbonates. Okay. And next part is metal hydrogen carbonates. Metal carbonates, what they give? They give salt and carbon dioxide. Now, metal hydrogen carbonates which are there, when they react with acids, they give you salt. They also give carbon dioxide gas, but along with it also water is generated. Okay, so this is additional point that you have to remember when acid is reacting with metal hydrogen carbonates. Okay, moving on to next. This is important thing to know. When an acid reacts with a base, we get salt and water. Okay, this is called as the neutralization reaction. Okay, the resultant which comes is a neutral media. Okay, an acid and a base is reacting, we get neutral, that is salt plus water. Okay, very important questions. Most of the time this come, you have to know its definition. Define neutralization reaction. If this question comes, you have to write it in very simple manner, that when an acid and a base reacts to give salt and water, this is known as neutralization reaction. Okay, most of the time this comes for 1 mark. Okay, so this is easy part. Now, next thing that we have to know in this chapter are some of the properties. That metallic oxides are basic in nature. Okay, metallic oxides are what? Metal along with oxygen, when they react, the metallic oxides which are formed, they are basic in nature. Okay, you remember this point. Then next point to remember is non-metallic oxides. Metallic oxides are basic in nature, while just the opposite of it, that is when the non-metallic are reacting with oxygen forming non-metallic oxides, okay, are acidic in nature. Okay, just the opposite point of this. Okay, but you have to remember which is for what. Then this is an important point in this chapter, as we are talking about acids, bases and salts along with this. Okay, now alcohol and glucose, they do not conduct electricity. In now alcohol and glucose, why they do not conduct electricity? This question can come as a give reason, it can directly come as the answer. Okay, the simple reason is because they do not form what is called as the ions. Okay, the ions is responsible for conducting electricity. Okay, and if in a solution there are no ions only, then it cannot conduct electricity. So simple thing to answer, that alcohol and glucose are not able to conduct electricity. Why? Because they do not form ions. Simple answer. Acids produce H plus ions. Now this thing is, you have to know that acids are producing H plus ions when they are dissolved in water. Okay, when you dissolve acids in water, what is formed? H plus ions are formed. Whereas to the contrary, when bases dissolve in water, they form H minus ions. Okay, acids, when they dissolve in water, they form H plus ions, and when bases are dissolved in water, they are forming the OH minus ions. Easy to understand. Now, this is important point. Dilution of acids is done by adding acid slowly to water with constant stirring. Now, dilution. What is the meaning of dilution? Dilution is making an acid, I won't say weak, but just reducing its power. Okay, so that while you are using it in the laboratory, now the acids which you all use for your practicals in your laboratory are diluted acids. Now this is done so that they are not very concentrated, you can use it. Okay, now this dilution of acids, how it is done? It is done by adding acid slowly to water. It's not vice versa. You cannot do it vice versa, but it is adding acid slowly to water with constant stirring. Okay, now why this is so? This is a question that most of the time comes as a key reason. This is most of the time repeated question that comes for your board exams. Care should be taken while adding concentrated acid to water. Now, see this point, adding acid slowly to water to dilute. Before dilution, it is a concentrated acid, that it is a strong acid. Okay, it can keep you burns if it falls in your hands. Okay, now this concentrated acid is slowly added to water. Now, why care should be taken? This is an important question. Let's see what is the answer is. Okay, dilution of acid is done slow as adding acid slowly with constant stirring. It's the same point to the water. You have to write this point first, that how it is done, adding acid to water. Now water should not be added to the acid. There is a reason why this cannot be done, because this reaction is highly exothermic. Now this exothermic we have learned in the last chapter. In the previous chapter we have learned in chemical equations. Okay, you have learned this. If you have not seen that video, you can go in the playlist and you can watch the previous video which I have released. In that I have explained what is exothermic. Okay, in simple word, what is exothermic? Heat is given out. Okay, so heat is given out, so there can be splashing out of the mixture and cause you burn if you are doing it in hand. Okay, and if you are adding water to the acid, that can splash out, that even the glass which you are using can break, okay, and cause you burn. So this is the simple reason, okay, that care should be taken while adding concentrated acid to water. Along with this, also the answer comes for this point, okay, that dilution of acid is done by adding acid slowly to water and not vice versa. Okay, simple point, answer is, it is the reaction is highly exothermic, and this point, the heat generated may splash out and cause burn. Okay, this is, you have to know. Next part of this chapter is pH. What is pH? pH is nothing but the power of hydrogen. The amount of ion concentration of hydrogen is there in a solution, that number is given as the pH of the solution. Okay, now pH of a neutral solution is 7. This you have to remember. Most of the time question comes on this. What is the pH of a neutral solution? What is the pH of a acidic solution? Okay, or simply a pH is given in you have to identify either the given solution is acid, basis or neutral. Okay, then acidic solution is less than 7 and basic solution is more than 7. The pH of the basic solution is more than 7. Okay, so this pH value you have to know that the midpoint is 7. There, see, this is a simple thing. I will tell you this. See, this is a midpoint. This is 7 here. Okay, this is your 0 here, and this is 14, which is the maximum. Okay, if your solution is neutral, it is exact 7. If it is exact 7, it is neutral. Anything less than 7 is acidic in nature, and anything greater than 7 is basic in nature. Okay, so this part is all acidic and this part is all basic. Okay, easy to understand. Next thing, are acids are differentiated into two types. There are strong acids and there are weak acids. Now, acids that give rise to more amount of H plus ions are termed as strong acids. Okay, this is the definition of strong acid. Okay, sometimes we don't remember this and write anything that acid which is more strong is called strong acid and like that. It is not. The answer is this simple answer. The acids which is producing more amount of H plus ions will be considered as a strong acid. Examples of strong acid you have to know: H2SO4, HCl and HNO3. What is H2SO4? This is sulfuric acid, this is hydrochloric acid, and this is nitric acid. These are strong acids. While on the other hand, just the contrary part, that is the acids that gives rise to a less amount of H plus ions will be termed as weak acids. Okay, example of weak acid: acetic acid, oxalic acid, and citric acid. Okay? There are many more examples, but these are simple enough to understand, which I have given you. So you all can just learn these examples, and that is more than enough for you. Okay. Next part is acidity. Now we all know that there is secretion of HCl in our stomach. Okay, and it is for good sake that HCl is there in the stomach. But sometimes it happens that there is an excessive secretion of HCl. Okay, sometimes due to some reasons there is excessive secretion of this HCl, and these causes pain and irritation in stomach. Okay, this phenomenon is called as the acidity. Okay, now what can you do to get relief from this acidity? You have to use something called as antacids. What are antacids? It is the anti-acids. You can call it antacids. Okay, acidity can be relieved by consuming this. Okay, example is milk of magnesia. Okay, you have to know this example. This is the important part in your textbook, which is that you have to know this, because most of the time this come as a correlation question or a state question. Name the following question. Tooth enamel, that is the tooth part. Tooth enamel is made of calcium phosphate, and this calcium phosphate which is there, it is the hardest substance in our body. Important point to remember that calcium phosphate is the hardest. Most of the time this question comes as name the following. Name the hardest substance in the body. The answer will be calcium phosphate. The answer is not tooth enamel. Okay, tooth enamel is made of calcium phosphate. Okay, and this calcium phosphate which is there, this is the hardest part of substance in the body. Okay, then this is important. Chlor-alkali process. This is the process. You have to know the definition. Now I'll try to make you all understand this definition in a very simple manner. Okay, now you just have to imagine something. Chlor-alkali process. I will tell you the name of this. Okay, have to remember by this name, but before that let's see the process. Now when electricity is passed, first thing, electricity is there. Okay, it is passed through a aqueous solution. Okay, second thing, what is the aqueous solution is there. Okay, first thing is electricity, second thing is this aqueous solution is there of sodium chloride. Aqueous solution of what? Sodium chloride. This is the third part. It decomposes. Fourth part is what? That whatever that is given to us, it decomposes. That this part is getting decomposes, and to form sodium hydroxide, this is fifth part, chlorine gas, sixth part, and hydrogen gas. Now I have done this thing, splitted this, because this is the important question. It is coming most of the time after every 2 years, or sometimes every year. This question is coming, and not just this question, based on this statement, the rest of the part which is left, that is the applications of most of the things, are related to this. If you have learned this concept well, you are mastering in this chapter, I'm telling you. Okay, so when electricity is passed, let's break this. Now let's imagine this thing. Okay, electricity is passed through aqueous solution of sodium chloride. So sodium chloride aqueous solution is kept there, and we are passing electricity through it. So this sodium chloride solution which is there, it is getting decomposed and forming three products. Decomposition reaction, if you remember what is happening in decomposition reaction, a single reactant is broken into two or many products. Okay, this is the simple example that sodium chloride, one single reactant, is breaking into three products. First thing, sodium hydroxide, second is a chlorine gas, and third is a hydrogen gas. Okay, so these three important products are released during this chlor-alkali process. Now why chlor-alkali process? This name is there. You see, there is a chlorine gas which is released during this thing, and there is an alkali. What is an alkali? Alkali is nothing but a base. Base, that is a sodium hydroxide. This is a alkali. Okay, alkali this is called. Okay, so chlorine and an alkali is released. Therefore, this is called as the chlor-alkali process. Okay, Now in this you have to know this two gases which are evolved, that is a chlorine gas and hydrogen gas, but you have to also know which is the part that descends. This is again a sure short question, most of the time repeating question. Now I have telling you many things which are repeating, and these are small parts that are repeating question. And I'm telling you that first two chapters of science textbook, mostly small questions are coming from this, because there is nothing much in this chapter, and these small questions are very important. Now I'll tell you how to remember this. Hydrogen gas is released at cathode, is evolved at cathode, and chlorine gas, which is it is evolved at anode. How to remember? C. Cathode is C and chlorine is also C. You just say that these are never meeting. Okay, this point you have to remember that these points never meet each other. Okay, C, this C is the and cathode C. So if you know this one point, the other point you can easily remember that hydrogen is for cathode and chlorine is for anode. Okay, moving on to the next part. Now these are some applications of whatever the products that are released from the chlor-alkali process. Of that, many other products can be formed. Okay, so we are learning this other products which are formed from the chlor-alkali process. Okay, first thing is baking soda. Baking soda is, the chemical name is sodium hydrogen carbonate. The important point that you have to remember in this is that it is a mild base. What is a mild base? Mild means I don't say it is a weak base, but a weaker type of base. Okay, so sodium hydrogen carbonate is a weak base which is there. We call it a mild base. You have to know its uses. There are two uses given there. You have to know both of this, because if any one is asked, you can remember. If you forgot the other thing, you can always remember the second part. Okay, an ingredient of antacids. Baking soda is used in making antacids. Okay, it is also used in making soda acid fire extinguishers. What are fire extinguishers? They are used to extinguish fires. Okay, you have to know this point that baking soda is used for what. Okay, next is plaster of Paris. This is again an evolved from the chlor-alkali process products. That chart which is there in your textbook, you can refer to that chart how it is formed. Okay, I'm not going to discuss that. I'm telling you what is important in that part. Plaster of Paris, also called the POP. You have to know its formula, that is calcium sulfate dot half H2O. This plaster of Paris is prepared by heating gypsum. This is the important point again, that plaster of Paris is prepared by heating gypsum. Then you have to know its uses. There are many uses to this, but these are important points that you have to know. Okay, making toys and decoration materials. You must have listened about the making of Ganesh idols of POP. Okay, but it is not advisable to use that because it is polluting the nature. Okay, that is the point. Making toys and decoration materials. Okay, for supporting fractured bones. You know, when anytime if you have seen your friends having the fractured bones and they tie something on their hand, white thing, and you know what is there to put there by doctors? It is nothing but plaster of Paris which is there in order to support the fractured bones to get into fixed position. Okay, these are uses. Next part is washing soda. Washing soda, that is the sodium carbonate, is used in making borax. This point you have to remember, it is used in making borax. Now in this nothing much to remember. You have to know its uses and that will be more than enough. Okay, next thing, to remove the permanent hardness of water, used in glass, soap and paper industry. Okay, so these are uses that you need to know from this chapter. Next thing is bleaching powder. Bleaching powder, you can know this formula, then used for bleaching cotton and linen. Okay, you know that bleaching powder is used in a disinfecting water also. Okay, it is added to a water so that it acts as a disinfectant. Okay, then bleaching cotton and linen. Okay, these points you have to know. Now these are some of the acids you have to know that are present in different types of things. First thing, in tomato, what is the acid present in tomato? It is the oxalic acid. These are simple things. These are things that are found in and around side, and we don't know it. So as a science student, you have to know this. What are the different types of acids found in the thing? Okay, first thing, in tomato it is called as the oxalic acid. Then acid in tamarind, it is the tartaric acid. Okay, these points are important because most of the time a correlation type questions come on this, because you can correlate many things like tomato is to oxalic acid and tamarind is to what. Okay, this type of question can come, or simply name the following simple state questions. Okay, and next is stinging hair of nettle leaves. This is then a textbook. It is having the methanoic acid. Also the same acid is present in the bee sting. Okay, in the simple thing to remember, when anything stinging is coming, like stinging hair of nettle, or anything bee sting is coming, so the sting word you have to remember that nothing but it is a methanoic acid which is present there. Okay, then fifth thing, lemon you have to know it is the citric acid. It is the lemon, it is present in lemon. Okay, vinegar, acetic acid is there. Okay, and this is easy thing, you know, in a stomach HCl is present, hydrochloric acid is present in a stomach. Okay, now with this we are finishing with the chapter acid, bases and salt. If you have any queries, you can put them in the comment box. All the best for your board exams. Okay, if you like this video, please put a like on it, share this with your friends and family, and again your doubts can be put in the comment box, and finally subscribe to Sudip Tech Learning.